Hello, my name is Grayson Lovett, and this is my Lab 2 implementation. I will start with the first finite state machine and then move to the next. So here is my first finite state machine. Here is the circuit implementation of my first finite state machine. This is the decoder, NAND gate, and D flip-flop. The NAND gate I also utilize as an inverter, connecting both pin 15 to two different inputs of the NAND gate to simulate a inverter. D0 is the input towards the decoder. D1 is the clock of the D flip-flop. D2 is the clear bar. And then D6 is the first state and D7 is the second state. And it's all according to this pin diagram here as well. So going through, doing anything with the clear bar not on gives me nothing. So I have to first turn that on. And then if I leave the input as 0, and I should be able to cycle through all of the states, which I can. So state A, state B, state C. And it stays at state C, and so an input of 1 comes through, then it goes back to state A. And also, once it's at state B, an input of 1 sends it right back to state A as well. And that is how it should work. Now, here is my second state machine implementation. Here is my implementation for the second state machine. I used the same wiring all the way through except for around the decoder and NAND gate. So those are the only differences here. So the input 0 is, or D0 is still the input. D1 is the clock and D2 is the clear bar. And then D6 is the S0, state 0. And D7 is S1, or next state 1. And going through the truth table, first you have to, or anything with clear bar set to 0 doesn't work, so it has to be set to 1. But to go through the states, I start at state A, and with an input of 0, stays at state A. Input of 1 goes to state B, and then an input of 1 again goes to state D. Input of 1 again goes to state C. And then it cycles through those for all inputs of 1. And anytime an input is 0 at any state, so here's state D, input 0, goes back to state A. And then state B, input 0, goes back to state A. And then state C, input 0, goes back to state A. Thank you for watching. These were my implementations for the first and second state machines.